Mrs. Pettit, I hope you guys are doing well and studying for your exam. I wanted to kind of go over a couple of these homework problems, and I'll go over as many as I can and post a video up for you guys, and hopefully that'll help you guys a lot. So, on number 19 in section 1.1 of the book, it starts with attitudes towards recycled products. And recycling is supposed to save resources. Some people think recycled products are lower in quality than other products, a fact that makes recycling less practical. People who actually use recycled products may have a different opinion about those who don't use it. Here's data on the attitudes towards coffee filters made of recycled paper among the people who do and don't buy these filters. Okay, so I copied the table down right here. Okay, so what happens is we have people who are buyers and non-buyers. So, and then this is a two-way table where you think they have the people who think the quality is higher, the same, or lower. Okay, and then the first question is, how many people does this table actually describe? So one of the things that you always want to do when you have a two-way table is to sum up your columns and your rows and make sure that these guys all match up. So what happens is I add these up right here and I get 36, and 29 plus 25 plus 43 is 97. And 29 plus 25. Yes. And then I get these and I add them together and I get 133. And then I double checked that these also add up to 133, and they do. So there's a total number of 133 people. And then the other part was how many of these people were buyers of coffee filters made of recycled paper. So there's 27 and 9 that all bought them, right? So there's a total of 36 who bought coffee recycled papers. And then on B, it says, give the marginal distribution of opinion about the quality of recycled filters. So the marginal distribution of opinion of the quality. So we've got 49, 32, and 52. These are your marginal distributions. And then what percent think the quality of recycled products is same or higher than other filters? So there was 49% that saw 49 out of 133, which is 36.8%, that thought it was the same. I'm sorry, that higher. And then there's 32 out of 133, which is 24%, which is the same. And then 52 out of 133, that was 39, which is 39%. So percent of people who think it was the same or higher, I added this 36 plus 0.8 plus 24, and I got around 60.8. Then moving on to number 21, they said create, and I'm sorry about my ugly handwriting, but it said exercise 19 gives data on the opinions of people. To see the relationship between the opinions and experience with the product, find the conditional distributions of the opinions for buyers and non-buyers. What do you conclude? So what I did is I went ahead and took the conditional distributions out of the total of the buyers and the non-buyers. So I used the total for the buyers, which was 36, and the total for the non-buyers, which was 97, and gave conditional distributions for those. And from there, I can say that buyers are much more likely to think the quality is higher. So here you see how much of them think that the quality is higher, but there's a lot of non-buyers that think the quality is lower as well. So you could also say that. Okay, pretty sure that's all in 1.1, I think, yes. So moving on to section 1.2, we had 67. So I'm going to move to that problem. I'll get better at this, guys, I promise you. So number 67 says, a survey of a large high school class asked the following questions. Are you female or male? Are you right-handed or left-handed? And what is your height? And then which ones match with which? Okay, so this one was kind of a weird question. So not a one that I absolutely love, but I thought it was interesting and nonetheless. So what we're supposed to do is match up, and I'm going to move my camera, so I hope I don't make you guys dizzy. I'm sorry if I do. Okay, so I have to match up these graphs right here with which one of the questions that I've got. Okay, so let's take a look at them. So A, we have a distribution, looks like it's skewed right. And how many, let's see what we would do. A is probably the amount of studying that you do because it does vary, right? Now B is all or not, like there's a huge amount that are B and a huge amount that are a small amount that aren't. So I would say that's right-handed and left-handed because there's a much higher percentage of people who are eight-handed. About 90% of the population is right-handed. So this kind of matches that distribution like a 90-10. Okay. And then C, this is another one where it's yes or no. So this would be the male-female one, right? And then this normal distribution is what is your height in inches? So that would be much more varying, but it would actually be normally distributed. So heights are much more likely to be normally distributed. So that's why that one would match up. 68 said, what type of graphs or graphs do you plan to make in a study of each of the following issues at your school? Explain why. Okay, so one of the things is which radio stations are most popular with students? That's a categorical question. So I would use a bar graph with any categorical question, okay? Unless it was like out of, like, remember when we were taking percentages of a class, if we were trying to find out what percentage of you guys prefer this as your color or red as your color or blue as your color, that would be okay for a pie graph, but any other category, I would do a bar graph. The other one is how many hours per week do you study? That's a quantitative variable. So when you do quantitative variables, you want to do stem plots, dot plots, or histograms. Okay, anything that shows this kind of distribution. And then calories consumed per day, that's also quantitative. So again, stem plot, dot plot, or a histogram. Okay, so that was all the questions that I had for section 1.2. I did have some in 1. Oh wait, I had another one. I think it was 91 and 1.3. That's 1.3. So let's go to 1.3. And again, sorry about the camera moving. Sorry. Okay. I'm gonna do number 91 with you guys in I'll do that as a separate video because I'm going to do a box plot for that. But let's do 108 and 110. 108 said you have data on the weights in grams of 5 baby pythons. The mean weight is 31.8 and the standard deviation is 2.39. The correct units for the standard deviation are what? The correct units are grams. When you're doing standard deviation, sorry kiddos, when you're doing standard deviation, you're always in the same units as your original data. So the mean, standard deviation are all in the same units. The only thing that doesn't have a unit is your z-score. Okay? Now, 110 says, what are all the values that a standard deviation could possibly take? And that's right here. It has to be greater than or equal to 0. It can be equal to 0, but it has to be greater than or equal to 0, and it sure as heck can't be negative, okay? And it can be greater than 1, as we've calculated before. So, okay. So those are the ones that I did first. So I'm going to come back and do the box and whisker plot and show you guys how to do that in your calculator. That'll be number 91. So I hope this is helpful. I'll get better at this, I promise. I'll talk to you guys soon, and thank you for watching.